Alrighty, so my first step is going to be to weigh and record the mass of an empty styrofoam cup. So I've got that here, nice and dry. Always when we're weighing something, we zero the scale, also known as taring the scale, T-A-R-E, not T-E-A-R. Okay, and so 1.85 grams. That last digit's going to fluctuate a little bit. We call that the uncertain digit. Since it's going back and forth between 5 and 4, you can record it however you prefer. I'm going to go with the 5. So 1.85 grams. Okay. All right. Next up, I've got an Alka-Seltzer tablet that I'm going to put into the cup, and I'm going to record the total mass of the Alka-Seltzer and the cup. Okay. Total mass of the cup and the Alka-Seltzer tablet. So here's my tablet. And very simply, I'm going to drop it in, okay? All right, and let that settle. And so 5.07 or 5.08, again, it's going back and forth. I'll go with the 7 this time. So 5.07 grams, okay? Now, the mass of the Alka-Seltzer tablet is just going to be the difference between these two lines, okay? And the reason for that is the only difference between these two lines is one has the cup, right? One has the cup and the tablet. So if I subtract out the cup, right, I'm going to just have the tablet. So this minus that would give me the mass of just the tablet, okay? Alrighty, so next up, I'm going to do the graduated cylinder. So I need to have the mass of an empty graduated cylinder. Okay, again, make sure that this is zeroed out. It's already on 0, but do it again just in case. All right, empty graduated cylinder there. And it settled out to 45.70 grams. All right, so again, I'm going to skip this line. This will be for people to do on their own. But for the graduated cylinder, it was again 45.71 grams. So 45.71 grams. Okay. Now I'm going to add to it some water. Okay. Now my instructions had to measure out about 100 milliliters of tap water. I'm going to change that to 70 just because the scales actually cannot measure that high. Okay, so it can only measure up to about 70 milliliters with the mass of the graduated cylinder. So just an adjustment we made in class. Okay, I'm going to do that, and in 1 second, I'll be back. Alrighty, so I've got my 70 milliliters of water. Now, two things. Number one, for some people, this might look like it's 71. You won't really be able to see it on the camera, but one thing that we learned in class is that when you put water into a graduated cylinder, it has what we call a meniscus, which is a curve in the water due to the attraction between the water molecules and the edge of the container. So it actually looks a little bit higher than it actually is. So I have overfilled it just a little bit. And I used that meniscus, the bottom of it, to see how close I could get it to 70. Now that's the first thing. The second thing is also that we actually don't need exactly 70 milliliters here because the reaction isn't dependent on how much water we have, as long as we have a surplus of it. So plenty of it, which in this case we do. So what we're actually going to do is we're going to measure the mass of the graduated cylinder and the water, and that's going to get us a more accurate measurement by mass. Okay, so now we've gone up to 115.02, and again, that is my mass of the cylinder and the water. Okay, so that was 115.02, 115.02 grams. Okay, now my next line is the mass of water used. Okay, now again, this is going inside of the cup. So what we're going to do is we're going to subtract this number, the 115.02 grams, minus the mass of just the cylinder, okay, the 45.71 grams, because that's going to give us just the mass of water that's going inside of our cup. Okay, so again, the cylinder and the water combined minus just the cylinder gives us just the water. Okay, so now I'm going to take my water. I'm going to add all of it to the cup. Okay, and if you're unfamiliar with Alka-Seltzer, this is what we call an effervescent reaction or effervescence reaction. You won't be able to see it too well, but I'm sure you can hear it. All right, so an effervescent reaction is one in which a solid reacts with a liquid to produce a gas. At least most of the time it's a solid and a liquid. And so what we're making right now is CO2. Okay, now the fact that we have an open container is strategic because we want as much of that CO2 to be released from the cup. That amount of CO2 is our mass lost in the reaction, and that's what we're going to use to backtrack and try to be able to calculate the percent that we've lost. And that's going to essentially give us the amount of sodium bicarbonate that was left, or rather that was started with inside of that tablet. Okay, and we'll go over those calculations on Wednesday. Obviously, this is Tuesday that you should be watching this. So here's what we're going to do. Okay, this, as you can see, probably there's plenty of bubbles in here. That CO2 needs to come out. So what I'm going to do is I'm going to let this go for another minute or so, and then I'm going to start tapping the sides of the cup gently. Okay, all around. Okay, bottom, top, left, right, diagonally, however I can, because I want to get as much of that CO2 out as I can. All right, otherwise I'm not going to lose as much mass as I should, which means I'm not going to calculate as much sodium bicarbonate in the tablet as I should. Okay, so I'm going to do that for a few minutes and then we'll come back for the final measurement. Okay, so it's been about 5 minutes or so. I gave the cup plenty of taps all around. Again, you probably won't be able to see too much, but we can see there's still a few bubbles left over at the bottom. For the most part, the bubbles are gone, which means the CO2 has escaped. Okay, now if you want to be really efficient and really accurate in this experiment, you do want to sort of leave this out for a good while, you know, an hour, maybe hour and a half. But that's okay. This is good enough for us. So we're going to now weigh the cup after the reaction. So this is the final mass of everything together. All right, and 73.40 grams is what we end up with. So that is the mass of the cup and the reaction mixture after the gas has left. Okay, so again, 73.40. Okay, grams still. Now, again, I have left these empty lines, the bold lines empty for you all to do the calculations with. Somehow there are still bells after school. Anyway, so mass of cup plus reaction mixture without the gas, obviously that's left. So that's what we have here. Okay, this is after the reaction. Now, again, we want to think about what we put into the cup. What did we put into the reaction mixture? So we put in a tablet of Alka-Seltzer and we put in water, okay? And this is what we have left over, but I need to get rid of the mass of the cup, okay? Because I don't care about the cup, I only care about what's inside the container. So to get this last line, I'm going to take this measurement and I'm going to subtract out the mass of the cup. Okay, so by the time you come to class tomorrow, I need you to have filled out these 3 empty boxes. Again, using the tips that I gave you, you can go back and rewatch the video if you need further instruction with that, or you can very simply just look at the instructions that says when to subtract and what to subtract and all that, okay? And then tomorrow in class, we'll explain how the input mass, okay, these two, versus the output mass, or essentially what we are left over with, can be used to determine not only how much CO2 was produced, but also how much sodium bicarbonate was in that original tablet. Okay, thanks for watching, and I will see you tomorrow.